So recently we constructed 6 triangles that all had the same given 3 side lengths. Frodo was absent during this lesson, again, off on some quest apparently. Frodo says, I constructed the 2 triangles on the left. They are not congruent because they don't look alike. Explain to Frodo how you know the triangles are congruent. Well, again, he said that they look different, so they're not congruent, but he's actually wrong because look at the side lengths. The top triangle has side lengths 5, 6, and 7, and the bottom triangle also has side lengths 5, 6, and 7. So that is definitely going to create 2 congruent triangles. That's one of the triangle congruence theorems we've looked at in the past. Again, if all 3 sides of one triangle are congruent to all 3 sides of another triangle, then the 2 triangles are congruent. So that's what we're going to say. We're going to say, Frodo, the 2 triangles are congruent by side congruence. Again, without writing out the entire definition for side congruence, remember it's that all 3 sides of one triangle are congruent to all 3 sides of another triangle, and that would be enough to prove the 2 triangles are congruent. Okay, so again, explain to Frodo how I know. Well, I know because of side congruence, and I believe in the next slide or 2 we're going to define that anyways, what side congruence is. So I'll just leave this for a few more seconds, but I'm going to go to slide number 2 right now. Alright guys, slide number 2. So see here in slide number 2 we have one sec actually, plug in here. So there are 6 ways that we have learned so far to show that 2 triangles are congruent. The 6 ways are given on the right. Explain in your own words how you can use each of them to prove 2 triangles are congruent. So I know it says in your own words, but I feel like I should definitely facilitate this a bit. So how do I prove triangles are congruent through rigid motions or transformations? How do I prove triangles are congruent through side congruence theorem, side congruence theorem, angle congruence theorem, angle side congruence theorem, and hypotenuse leg congruence theorem, right? How do I use these to prove 2 triangles are congruent? I'm supposed to explain for each one, so I think you should either go ahead and do this in your own words or follow my lead, right? So the rigid motions, right? I can rotate, reflect, or translate one triangle perfectly or directly onto another triangle to prove congruence. Again, so if I'm trying to prove 2 triangles are congruent through rigid motions, I can rotate, reflect, and or translate one triangle directly onto another triangle to prove congruence, right? Remember, if they map I'm going to throw that in here, or translate to map one triangle directly onto another triangle to prove congruence. Remember, we did that in DESMOS. We mapped one triangle onto another by either flip, turn, or slide. The side congruence theorem says this. It says if all 3 sides of one triangle, after this one we can copy and paste and edit for the other ones. So again, side congruence theorem says if all three sides of one triangle are congruent to all three sides of another triangle, then the two triangles are congruent. By side congruence. Okay, so again, side congruence theorem says if all three sides of one triangle are congruent to all three sides of another triangle, then the two triangles are congruent by side congruence. Okay, now I can copy and paste for the rest, and copy, paste, and edit. So I can copy that. Hopefully you know the shortcuts for copying and pasting. If you don't, hold Command and press C to or highlight it. Hold Command and press C to copy it, then hold Command and press V to paste it. And now I'm looking at side congruence theorem. Side congruence theorem says if, let me edit this. If two sides, notice how there's two S's. Oh, whoops. And notice how the A is between the two S's, meaning it's in between, the angle is in between the two sides. So again, side congruence theorem, the angle is between the two sides. So if two sides and the included, notice how the A is included between the two S's, so if two sides and the included angle of one triangle are congruent to, I'm going to copy and paste this, two sides and the included angle of another triangle. Let me delete some of this. So far I have if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent by side congruence. Let's take a moment here to look at side, angle, angle. Let's take a quick look at some images. So SAS versus well, let's not even go there. Let's just look at the next one. Let's look at ASA versus AAS. Let's see what it shows. Oh, there we go. That's a good picture. So the next ones are angle, and angle, side. And what you want to know about, really about all of them, is kind of how they look. So this is angle, this is the one we're about to define. Notice how an angle, the side, the S, is between the two angles, the S is between the two A's, aka the side is between the two angles. And then when we get to the one after this, it'll be angle, side. Notice how the S is not between the two A's. That's because angle, side uses two angles and a side that's non-included. Right? So again, angle, the side is between the two angles or included between the two angles, and angle, side, the side is non-included or not between the two angles. So we can come back and look at that image in a sec, but either way, let's go back to that DESMOS. I'm going to copy and paste this here. I'm going to copy that, and I'm going to paste it in here for angle, and then edit. So angle, is two angles and the included side. So it's if two angles and the included side, okay, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent by angle, angle congruence. So, and let's go back and look at that again. Let's go back to the image I had. So again, angle, angle, you have two angles and the included side. Now when we go to angle, side, it'll be worded almost identical, except it'll say two angles and a non-included side. So all I'm going to do is copy and paste what I wrote for angle, angle, and instead of saying the included side, I'm going to say a non-included side, right? Included side is between the two angles, non-included side is not between the two angles. So I'm going to copy this, and I'm going to, dang it, copy that, and Command C to copy, and then Command V to paste. Angle side theorem. If two angles and a, not the, and a non-included side of one triangle are congruent to two angles, and a non-included side of another triangle, then the two triangles are congruent by angle side congruence. So again, I'm hoping you guys are following my lead here. Stop me if you want me to go somewhere else, want me to go to a different slide, or if you have a question. Okay, this last one deals with right triangles. Let's take a look at that picture one more time. So you have angle side angle, two angles and the included side, versus angle side, two angles and a non-included side. So that's what those words mean, right? The words we wrote mean images that look like this: included side, angle. Non-included side, angle side. So there's that. And then hypotenuse leg is for right triangles. So I'm just going to rewrite this one. I'm not going to copy and paste because everything is so different for this one. If the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the two triangles are congruent. Let me fix all these typos. Okay, so you know what? I'll copy and paste these last two into the chat. That way, if you're not all the way caught up, you can still copy. You can copy and paste those things. So there's the angle side one. What I just pasted in here was for angle side, but you can copy it and paste it if you haven't written it, and you can kind of then copy and paste for the SAS and the ASA and just kind of change it. And I'll also paste this one for hypotenuse leg into the chat. You let me know if you have any questions. And okay, so now I submit my answer. So now everything is showing. I'll stay on this slide for another minute or so. Give you guys a minute to kind of process, see if you have any questions, and then I'll plug along to slide 3 in just a minute. Again, just giving you a moment to kind of process / finish this slide, and like I said, I'll move ahead here in about 40 seconds or so. I'll move ahead. Excuse me. I think it's about that time. Been talking all day, so anyhow, let me plug along here, guys, to slide number 3. Slide number 3 is just some information, the introduction to proofs. If you in class yesterday, hopefully you had a chance to kind of have an introduction to proofs in class, because we did a couple fill in the blanks on some 2-column proofs in class. And now a couple more proofs here. So definition of proof: it's evidence sufficient to establish a thing as true. Mathematical proof: an argument that begins with known facts, or remember, given information, proceeds from there through a series of logical deductions, or like conclusions, right? So these are logical deductions or conclusions we can make based on things we know. It's not necessarily given information, but based on our knowledge, we can make some other conclusions. And then the proof ends with the statement you're trying to prove. That should make sense. If you were asked to prove something in this mathematical context, it would make sense that you end with, your argument ends with the thing you're trying to prove. So, one last thing here. A paragraph proof is what we're going to kind of use here, though. We can just write sentences. It's not going to be a 2-column proof. It's going to be a paragraph proof. And a paragraph proof is one way a proof is often written. The advantage of a paragraph proof is that you have the chance to explain your reasoning in your own words. In a paragraph proof, the statements and their justifications are written together in a logical order in a paragraph form. There's always a diagram and a statement of the given and proved sections before the proof. So you saw that in yesterday's class if you were able to have a look. You're going to be given a sketch or a diagram normally, or you're going to want to sketch it if you're not given that. And then and you're also going to be given some given information, stuff that's known, as well as something you're trying to prove. So let's go ahead and go to slide number 4. And you can see all the stuff's there. There's a sketch. There's a few pieces of information that are given, right? GI is congruent to FD, IH is congruent to DE, and HG is congruent to EF, right? So anytime I have given information, I definitely want to mark up my triangles, and then we're going to use that information to prove that triangle GIH is congruent to triangle FDE. So here's what I'm going to do first. I'm going to grab this little line tool, and I'm going to make it red, and I'm going to make it the thin pencil, or the thin writing tool. So there's that. Oh gosh, excuse me. Okay, so GI is congruent to FD. Again, I'm going to mark that with a tick mark. GI is congruent to gosh, excuse me. GI is congruent to FD. IH is congruent to DE. Well, not there. IH, put 2 tick marks on this one because it's not the same as the other one. IH is congruent to DE, so 2 tick marks, or double tick mark if you like. Definitely has to have a different amount of tick marks than the first pair. And the third pair here, HG is congruent to EF, triple tick mark. HG is congruent to EF. I'm going to put 3 tick marks on that one. Dang it. So it looks good. And notice the numbers are matching, right? The side that's 5 units long has 1 tick mark. The side that's 6 units long has 2 tick marks. And the sides that are 7 units long have 3 tick marks. There should be correspondence there between the the actual length or lengths and the number of tick marks. Don't forget down here, take a look, it's certain things that you're going to copy and paste in order to be able to write your proof. Let's try writing a proof for Frodo's triangles. Again, we labeled all the given information. We're trying to prove the triangles are congruent. Notice how we have all 3 sides of one triangle are congruent to all 3 sides of another triangle. So we, as in the first slide, we have side congruence, but we're gonna write it out in a paragraph proof. So we're gonna use sentences. So it is given that, right? I can copy this stuff. I think, maybe. I don't need to copy that though. I can just go, right? If I want to say GI is congruent to FD, I can copy some of this stuff. In fact, I can copy this right here in order to name the sides. I can copy this overline thing, Command C to copy, and then I can go back up to my little box here and I can click on the little radical symbol, and in the radical symbol, if I paste what I just copied, okay, that's not what I wanted to do. Again, in the radical symbol, if I paste, why is it doing that? No. Didn't mean to do that. Did not mean to do that. How do I undo what I just did? Undo. Okay, it's not working. Oh man. I did not want to do that. That's no fun. I kind of did something here I didn't want to do. Oh well, let me Sorry guys, things are getting a little weird here with this extra stuff that I accidentally put. Okay, it is given that. And then what I wanted to say is I wanted to list all this stuff out, so I wanted to copy this here in order to be able to name my sides like in the exact way that they should be named. So right here, that's what I want to do. I wanted to paste that. If I paste this little code here, it gives that little line. So what I wanted to say is GI, okay? GI is, now I'm going to copy this little symbol, this congruent symbol. I'm going to Command-C, copy that, paste it, and now I think I can just copy this again, this GI. I'm going to copy the GI, and I'm going to paste it here, and that's not what I wanted. Alrighty then. Oh, I know why, because I need to paste it inside of this little box with the radical thing, so... but GI is congruent to FD, so change GI to FD, and then let's see if this works. If I copy and paste, apparently I can't copy everything. Oh, okay, maybe I can. I don't know. Let's see how this. Let's see what happens here. Okay, perfect. So what I want to do is now say that IH is congruent to DE. So I just copied what I had did. And now I'm going to change the segments to IH and DE. Wait, what's Control Z to? Oh, my bad. You were telling me to undo something. It's Control Z. Sorry, kiddo. I get caught up sometimes doing my work, and then I don't catch everything. Is that what that is, Noah? How to undo something? Control Z. Yeah, okay. Well, I'll have to remember that one. Thank you for that. And then now I'm going to copy and I'm going to paste one more time, Command-V. That way I can say that HG is congruent to EF, right? I want to list all the given information, guys. Normally writing a proof, you just list out the given info. So I have EF here. So I've listed all the sides out, and we already kind of verified that these two triangles are congruent by side congruence. So I list out the three pairs of congruent sides to prove that, I'm just going to copy and paste this, to prove that these triangles are congruent. So I'm going to copy that, Command-C, or Control, depending on what kind of computer you have. This one is Command, but I know some of them are Control. Anyhow, if I copy that, that's what I wanted to prove, that the two triangles are congruent. Therefore, I can prove that triangle GIH is congruent to triangle FDE by side. I'm going to recopy this little congruent symbol so I can paste it by side congruence. Okay, and I would double check one thing. I would see the order in which they're named, if it's accurate. GIH, check it out. GIH, connect the dots. GIH. Notice how connecting the dots, GIH, you pass over 5, then over 6. So this one should be named in that same corresponding order where FDE passes over 5, then 6. Let's see if it does that. FDE. Connect the dots and notice how it passes over 5 and then 6. So then that tells me that they're definitely named in a corresponding order. So that's basically, if you have enough information to prove two triangles are congruent, then you should be able to write a paragraph proof kind of laying out all the information. So anyhow, I'll leave this up for a few more seconds and then I'll plug along into slide number 5. Again, I'll leave this up for a few, like 30 more seconds, just give everybody a chance to either take a look, or maybe if you have a question you can ask, but if not, you're definitely welcome to move ahead to slide number 5. One thing I will tell you is anytime you're doing a proof, you want to mark up the triangles. You want to mark them with tick marks or arc marks depending on what you know is congruent. So I'll leave this up again for a few. So slide number 5, I'm going to get into that. So like I said, you gotta label the given information. So it's already given here by diagram. It's given that angle J is congruent to angle M. That is marked, so that's given. Also given in symbol notation is that JK is congruent to KM. So I'm going to grab my little line tool here, and I'm just going to change it to red and to the thinner line. And I'm going to mark JK as congruent to KM. So JK tick mark and KM tick mark. Right? The tick marks, I'm using them to show this given information that JK is congruent to KM. And we could actually go ahead and fill in the given info on that note. We could say it's given that, and we can copy this little angle symbol here. It's given that, copy, paste. It's given that angle J is congruent to angle M. Let me now copy the congruent symbol. I just put both angles there, that I wouldn't have to copy the angle symbol again in between here. So now the congruent symbol, it's given that angle J is congruent to angle M. That was marked in the diagram, aka it was given. And, right, also this other thing was given, and that, let's see if we can copy this and paste it. Looks like maybe we can. Let's see, Command C. No, that's... Okay, so it looks like I have to use this thing to paste, this little radical symbol. Now if I paste that JK is, oops, congruent to KM, let me go ahead and just copy that also and paste it. Okay, I did that wrong again. Let's see. I just use your Command Z thing. That's awesome. Thank you for that. I have to use this little radical symbol, and I have to paste into the box for that to paste properly. So that's what was given, right? That's the given information. It is marked. But you also have to fill in this, I know that. This is what you're supposed to know. I don't know if you know it, but you're supposed to know that the vertical angles are congruent. I don't know if you remember this, but you got to mark that. And you're supposed to know that. This angle here, I'm going to call it JKN. I can't just call it K because there's more than one angle with that vertex. So I'm going to call this one JKN. Is congruent to MKL. And again, the reason I know that is because vertical angles are congruent. So I know that. Let me get the angle symbol again. Copy it. Copy that angle symbol. I know that angle JKN is congruent to angle, to angle MKL. Now let me get my congruent symbol. Again, I just did my angles first, so I wouldn't have to recopy the angle symbol. And there it is, guys. I know that angle JKN is congruent to angle MKL because vertical angles are congruent. Vertical angles are congruent. I know we're almost out of here, my friends. Go ahead and delete this. Therefore, I can prove that the triangles are congruent. I don't know if anybody already got this one. Do you know which theorem that we're going to point out? I'm going to copy that statement. And does anyone want to wrap it up for us with which triangle congruence theorem is needs to be applied here? Side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. Any takers on that one? Which one is it? I know it's 1231, so if you gotta leave, understood. But anyone want to chime in? Angle, angle, side, angle, side, angle, side, angle, angle, side. Well, I know we gotta get out of here. So look, guys, this one is angle, side, angle. Okay, by angle, side, angle, congruence. Let me just get my little congruent symbol. I can kind of have a full and complete thought. And good. Oh, whoops, vertical is spelled wrong. Okay, good. Alright, so I'll leave that up. You guys are out of here if you don't have questions. If you do have any questions, let me know.